Good afternoon, everyone, and welcome to today's video. Now, today's video will be about PCB prototyping. Now, if you're like me, you can't afford to spend hundreds of dollars every project ordering PCBs and different revs of PCBs from rapid prototype houses, nor can you spend the months it takes to get PCBs in, validate them, redesign, send the package off, and all those different types of things. It's a lot easier if you bring your own PCB prototyping in-house. Whether you're a hobbyist or whether you're a professional, doing it yourself saves a lot of time and a exorbitant amount of money, especially if you do have to do multiple revs. So today I'm going to show you my process of doing small runs of 1 or 2 PCB prototypes in-house, and hopefully you can learn something today. Now, my first step in making a PCB is to stage my components. So I usually buy components from Mauser or DigiKey in bags, and I normally keep them in the bags. I have a bin wall over against one of the walls here in my lab, and I keep all the bags in their own separate bins labeled, resistors from this value to this value, capacitors from this value to this value, this category, and such as that. So I found that keeping everything in bags is a lot easier than trying to put them into notebooks or trying to put them into 3D printed holders. Just keep them in the bags on the reels. It works so much better when you're building a lot of prototypes. Now, what I usually do is I'll take my bill of material. Now, I have 2 pages for this bill of material. It's 46 unique components, and I'll go down the list, and I'll usually start with capacitors, and I have those in order here, in order as they are on the bill of material. And then I'll go to resistors, and I'll put those in order as they are on the bill of material, and then I'll go on to different things like diodes and FETs and different semiconductors, and I'll go on down the line. I have my connectors down here that'll be soldered in last. So it is important to stage all your components and get everything ready for a build. This is an extra step that I usually do instead of going back and forth to the wall and getting my components and having everything strode about. I usually try to do this in order, and it helps the build go so much smoother and so much faster. So my first thing that I always do is always stage my components in order that I want to do them in the build. Helps things go a lot smoother. Now, my second step to the process is a stencil station. So you've got to add solder paste to your PCB in order to put surface mount components. And a lot of guys will take and put PCBs around and put the stencil on top of that, and it just gets complicated. You can order these from your PCB fab house for $10 or $12 and get it shipped with your order. Now, here I have a stencil station, and it's just a metal stencil station. It costs about $300 or $400. Has this nice plate that has all these holes that are drilled and tapped for these standoffs that you can put in. So I put my PCB in there. Stencil has a frame that goes right into the stencil station. You set it down, you line it up, and you can put your paste across it. So step number 2 is the stencil station. I would highly advise that you get a stencil station. You don't necessarily need one if you are just a hobbyist or something, but if you're a professional and you do a lot of PCB prototypes, I would definitely get a stencil station. It makes a world of difference when you're just trying to rapidly get a prototype out and tested. Now, sometimes on my stencil station I have to put a weight. This is just a stack of PCBs. Sometimes when the fabs are warped, and this one is a little bit warped, it doesn't want to sit square in the stencil station, so I put a weight different places in order to help the stencil bend around the PCB. But I'm not the best. I'm just using normal chip quick. Focus. I'm just using normal chip quick solder paste, but I'm not the best. So I usually just take a little bit of solder paste, just a little bit, not a lot, and take and stick it on there with my butter knife that it come with. Then I'll take and my squeegee and just squeegee it over. And this solder paste is a little bit old, so it's coming apart. It's a little bit stringy, but it will be fine just for prototypes. So all we're doing today is just prototype PCB. So it'll be fine. All right, and there we go. We have a nicely, freshly pasted PCB ready for assembly. All right, now that we have our PCB in place, now comes the tedious job of placing every single component on this PCB. This is the longest part of the process, is placing every single one of these components on this PCB. So that's what I'm going to do now, and take my tweezers and place all these components, and then we'll be ready for reflow. And once you have your beautiful PCB all populated, it is time for reflow. Now here's my reflow oven. It is a Chinese T962A. I have a video previous to this one of where I modified it with the with a temperature sensor and better firmware. Made by Unified Engineering. So if you're interested in modifying your Chinese reflow oven, feel free to do that. I normally take and I put 2 PCBs down underneath to lift the PCB that I'm reflowing off of the bottom. I don't know if there's any benefit to that or not, but I always do it, and I always have done it, and I've always got good results, so why change it, right? So let's go ahead and get this reflowed, and we'll see how it comes out. Okay, let's see how she turned out here. A little bit warm. Not too shabby, not too shabby. It looks like no tombstone components, maybe a few solder joints that need to be fixed a little bit, but for the most part, she turned out pretty good. Now, this method is not the most elegant, and this method is not the most professional, I guess you could say, or that kind of thing. We're not making production PCBs here. We're not making a beta run of 100 plus PCBs. When I do that, I use the pick and place machine and fresh paste and those kind of different things. But for making prototypes, just for validating whether or not a design works and if it has any bugs or kinks that needs to be worked out, this kind of method is perfectly fine. As long as you're safe, you know, you use ESD protection. Here in my lab, I have ESD dissipative carpet all throughout. All my benches are grounded and those kind of things. So as long as you have protection, this kind of method will work great for prototypes. So I hope you enjoyed today's video. Please like and subscribe if you liked it. Share it if you'd like to. And I'll probably make a new video, I don't know, about another 8 months from now. So be ready for that.